Welcome everyone to class. This is officially our last class for this program and this cohort. Um, it's just like we started yesterday. It just seemed like we started yesterday and everything went by like very fast. I remember a few classes away. I'm always talking about how many sessions um we've done so far and how many sessions we have ahead of us. Now we are in the last session of the program and I'm really happy because it's actually um it's actually a testament to your commitment, right? If you are not in class, this class won't hold or the classes won't hold. So kudos to you. You should actually be proud of yourself, every one of you that is here currently. It's not easy to stick to a particular thing for this long. Is especially data science. It's not easy to stick to it for this long. You've been exposed, you've been taught, you've been shown different aspects of data science, not just the class itself, but the variety night and every other thing, the assignment week in, week out, the coding, the errors you encounter, the setup, configuration, a lot of things, and you've actually survived them. You've been able to persist till this point. Um, you should be proud of yourself, honestly. You should be proud of yourself because assuredly, if you look back and compare yourself when you started, that is 3 months ago, with now, there is definitely going to be a difference. Yeah, you would see a significant leap in growth that you've actually moved from a particular level to a higher level. So yeah, I'm proud of how far we've come, and yeah, we've made a lot of progress. So I am just going to say that, and think we're going to have, let's say, because in the last cohort we did something. We used the last class to just we gave the last class to the students, so they come up and just talk about their experience so far and how this the program, data science program, has shaped them. Their what they've been able to learn generally, how they started, if they started with no knowledge, and how they are now, like what. So basically, just their overall experience. So we, if we can finish up with what we have for today, um, in time, we would give room for that. So if there's anybody that wants to, just like just to cap up the class, to close up the class, we just hear from you, because I've been the one mostly doing the talking all this while. So it's actually nice that we hear some of your voices. So that being said, we're going to be going straight to what we have for today. So today's class, yeah, we're going to be talking about regularization. It's going to be a brief class, but there is something I omitted, not intentionally. I actually was supposed to have discussed it during one of the classes, but I think due to one reason or the other, it skipped my mind. So we are going to look at that, which is the ROC code. It is nothing um it's nothing big, right? It's just a way to compare different models and gauge their performance. All right, and I'm also going to show us how to save our model. All right, after you've trained your model, how do I save it as a file? I said this yesterday. So you can just, let's say, have that saved, and if you want to send it to someone, you can do that as well. So yeah, that's going to be it. So now I'll be sharing my screen. Sharing my screen. Just give me a minute, please. All right, can everyone see my screen? Can everyone see my screen? Please confirm. All right, all right. So today we're going to look at regularization and some regularization techniques. So the essence of regularization is basically to help handle the issue of overfitting, right? So I said that in the last class yesterday. I kind of introduced it briefly, but today we're going to just look at it and how we can just use that in machine learning building ML model. All right. So let's just move on. It's not a very long topic. It's not complex as well. It's just a quick one. So we'll be done very, very soon, and then we'll move on to other things. So where was regularization? Now, from yesterday's class, I introduced a particular method of feature selection, which is embedded. All right, which is an embedded method. So and it is lasso regression. Or yeah, lasso regression. It uses regularization to kind of penalize our model or penalize some features, thereby removing them from our model if our model is actually overfitting. So, but today we are going to be looking at regularization generally and the different techniques of regularization. So, what's regularization itself? Regularization is a technique used in machine learning to prevent overfitting by adding additional information to the model. So, what you just need to know here is that regularization is used to what prevent overfitting. If whatever you are asked, or if someone comes up to like ask what regularization is, or in an interview and whatnot, just tell them that it is used to prevent overfitting. Right? That's the simple definition of regularization. So you already know what overfitting is. We've discussed that several times, so it's not a new concept to you now. So the importance of regularization, it helps to ensure that the model performs well on new unseen data by discouraging overly complex model. So this is the problem of overfitting, right? So still saying the same thing. So yeah, everything here is something you already know, like introducing overfitting and why regularization is important and all of that. Now we'll go straight to regularization techniques. Right, there are different types of regularization techniques that we can apply on our model. So the first one is L1 regularization. So this is the one we looked at yesterday. Okay, so we looked at L1 regularization yesterday. It's also called lasso, right? So it is used in lasso regression, but it can also be used separately in other ML model. But there's a particular regression that is embedded that embeds L1 regularization into, which is lasso regression. So how does it work? So L1 regularization adds the absolute values of the coefficient to the cost function. So this is the technical explanation of that. So as I said initially when I'm introducing ML and data science, that ML also comprise mathematics, right? All these things that are happening, they are based on mathematical functions and all of that. So I gave you the formula for linear regression and logistic regression. There are some other things as well that have formulas, which I didn't want to like bug you with because it's not really necessary to know at this point, but it's important to know as well, like moving forward. So, but there's what we call cost function. Cost function is what your ML model uses to it's what your model uses to determine the performance of your model, right? So when you are training a machine learning algorithm, the aim of that training is to what reduce the cost function. Okay, so the cost function has a formula. So each the cost function usually have a formula. So now when you are now applying regularization to your model, the there is an additional parameter that is added to the cost function. So I'm intentionally not bringing a formula here, but I just have this general idea of what it is. So the formula is there, right, for the cost function. But when you're adding regularization, some additional things are being added, all right, to your cost function, which helps to prevent overfitting. So that is basically what regularization is. So the L1 regularization does this, okay? So what L1 regularization does is that it drives some coefficients to zero. So remember what coefficients are. Coefficients are like the weights that are attached to each feature. Each features, right? So some of these coefficients, right? If your model sees that there is overfitting happening, like your model is overfitting, and need to look for those particular aspects of your model and the feature that is causing that, and then it kind of reduces it, it penalizes it by driving down the coefficient of that feature to zero. So if you multiply zero with your feature, so you know that it will be zero, thereby removing that particular feature. So that is why we classified L1 regularization yesterday as feature selection technique. Okay, so that is what happens here in lasso regression. So an example is this. An example of L1 regularization is used in lasso regression, as I said. So lasso regression is useful when you have a high dimensional data set with many features and you want to identify and retain only the important ones. So can you see it now? That's basically an application of L1 regularization. So lasso regression is not the same thing as L1 regularization. L1 regularization is a regularization technique on its own. Lasso regression is a model that has L1 regularization embedded in it, right? It is an adaptation of linear regression. So the difference between lasso regression and linear regression is that lasso regression has regularization embedded, so that if you use lasso regression on a model, like if you train your model with linear regression and use overfitting, you can train it with lasso regression, and you'll be sure that or certain that that overfitting is going to be reduced because the lasso regression has regularization, that is L1, which penalizes your model when it is overfitting. So that is basically what this is. So the advantages and disadvantages. So advantage of L1, it can reduce the number of features, making the model simpler and more interpretable, right? So you understand this already. Disadvantages, it may not work with highly correlated features as it tends to select one and ignore others. So that is it about that. You can see I told you about the formula here. I don't want to go too deep into the details. So this is your loss function, right? Your let's just say cost function, right? So this is the formula that uses to compute the performance of your model. So without regularization, it would just be this cost function that you have here, nothing else. But when you add regularization, you are adding this thing that you are seeing here now. This particular thing that is circled in red is your L1 regularization. So um yeah, these are all the mathematical notations and all of that. So remember we said that L1 regularization L1 regularization adds the absolute values of the coefficients to the cost function. So if you remember your mathematical notation, you remember that this is the notation of getting the absolute value of something. So you put that particular value into in this particular format. So let me not even go there because we don't want to to waste our time on those details. So, but just understand this. There's an additional formula or some additional parameters that we add to our function during regularization. So the other technique, regularization technique we have is L2 regularization, or what, ridge, or it is called ridge, right? The same way we have lasso, we have ridge, and same way we have lasso regression, we have ridge regression. Right. So what are the differences? So L2 regularization adds the squared values of the coefficient to the cost function. L1 regularization does what? L1 regularization adds the absolute values of the coefficients to the cost function. So this is the formula for L1 and this is the formula for L2. So you can see that this particular value here, Wi, is squared. Do you understand? Why this one, this Wi, right? It is the absolute value is gotten at this point, and that is what is added to the loss function. You can see there's also something here called lambda. So this is another parameter that we can actually tweak or fine tune or tune during our upper parameter tuning as well. So the same thing here too as well. So these are some of the things that you would be utilizing when dealing with overfitting. So the same thing, L2 regularization does not eliminate feature, but reduces their impact by shrinking the coefficient towards zero. So that's the difference, one of the major difference between L2 and L1. L1 actually drive some coefficients to zero, thereby removing them. But L2 doesn't drive them to zero, but can shrink them to be very, very low, so that if it has a high impact before, it will reduce it maybe from 15 to 2 or 0 point something, but it will not be zero, thereby retaining that feature in your data set or in the model. So an example is ridge regression. We have ridge regression. It's also a type of regression that is useful when you want to deal with or handle overfitting. So this one is useful when all features should be retained. So that's why we didn't put this as an example of feature selection yesterday, because it doesn't eliminate any feature. It doesn't select any feature. Everything is retained, but the impact of some of the features are reduced. You understand? So ridge regression is another example. It's an example of L2, which is useful when all features should be retained, but their impact should be minimized to prevent overfitting. So this is the advantage here: more stable and effective with correlated features, and does not perform feature selection. So all features remain in the model. So when you want all your features to be in your model, don't use lasso, use ridge. Or don't use L1, use L2. So the next one we have here is elastic net regularization. So elastic net combines both L1 and L2 regularization. So that's very straightforward. So since you already know what L1 and L2 regularization are, you know you can just know how to combine them. So what does this do? This actually balances the benefit of lasso, which is feature selection, and ridge, which is handling correlated features, providing a more flexible regularization approach. So you need to know when exactly you want to use L1, or you want to use L2, or you want to use the two, right? So that's where elastic net comes in. So it is best used when dealing with many features, some of which may be correlated. An elastic net can select features while also reducing the impact of correlated features. So remember we said that autocorrelation is not a good thing in ML. When you have features that are autocorrelated, you should remove one of those autocorrelated features. Do you understand? So read regression or else regularization handles that for you. When you have correlated features, it kind of reduces the impact of one of those correlated features. So the correlation, feature correlation will be reduced. So this is elastic net, right? So it is flexible, it balances feature selection and shrinkage and works well with correlated feature. Um, yeah, the disadvantage here is that it is more complex to tune due to the need to balance the two regularization parameters, right? So that's just what you need to keep in mind. So now the implementation, which is quite straightforward. Okay, very straightforward, and we are going to see how we can use it in scaling. So let's just go straight to our explanation sheets. So let's see how we can implement them. We have L1 regularization. So you actually, if you want to use L1, you can use it in lasso. All right, but this is when you want to, you are using linear regression. You can as well use, let's see, it in different other algorithms, right? Um, you can use it in logistic regression as well. You can use it in, let's see, you can use regularization here in SVM as well, right? So basically, you would see these things like as parameters when you are building your ML model. So let's just start with the lasso and ridge regression. So let's import lasso, import. So we're going to import this. So let's just import data set with using as well from data sets, import load um load, That's given us so this one is I'm going to just use this to also show us how to plot the ROC curve as well. So very important too. So mm, okay, so we are trying to import as many libraries that we'll be using in our code. So we're importing matplotlib here. Um, importing, let's import pandas as well. PD. Okay. So now that we imported our libraries, let's go straight to setting our data. Data equals to, let's call it housing action equals to true. X equals to data data. Y equals to data. So you can see our X here and you can see our Y. So this is a regression problem, all right? So let's split our data set. Splitting our data set. X train, X test, Y train, Y test equals to train test split equal to X, Y test size 0.2, and then we have random split equals to 14. Well, let me see the shape of X 20,000. Okay, let's make it 0.3 because we have a lot of this thing. So import linear regression here too. All right, so go straight to model training. Now, I just want to show us how we can use this regularization techniques. So the first one we're going to be looking at here is lasso regression. So can someone remind us again which of the regularization techniques is implemented or used in lasso regression? All right, exactly. So yeah, it is L1 bar. So we're going to demonstrate that. So to use lasso, you've imported it. So you can just come here and say lasso model and then set it up. I remember there was a parameter I told us about which is alpha. Let's check out the formula here. This alpha in the formula there's lambda, right? Lambda actually, but in the parameter name it's called alpha. So this lambda is a parameter that we can tune. So this parameter would let me go to the so this parameter here would determine how much regularization will be used. If the value is high, then the penalty will be high. If it is low, the penalty will be low. Let's look at the documentation to read it. So you can see alpha here. Let's so now you can see the losses regression is a linear model trained with L1 as prior regularizer. So are you understanding it now? So like basically we are the L1, the lasso regression is a linear model, is a linear regression model that is trained with L1 regularizer. All right. So that is just what you need to know. There's nothing different there. So this is just the formula. This is the additional thing that is added to your cost function. So all these things are just mathematical formula. So we'll see this. So you can see the alpha here, right? So the alpha is a constant. A constant is just a number, right? A constant that multiplies the L1 term controlling regularization strength. So the higher the alpha, the stronger the regularization. So if your model is overfitting very well, you can actually increase your alpha value to reduce it, to penalize it very well, right? But if you penalize it, if you over penalize it, you can actually risk your model becoming underfitted. You can actually make it start to underfit. So you have to ensure that you have that particular perfect alpha value that controls the overfitting and does not allow your model to start to go towards being underfitted. All right. So that is just a very important parameter you need to pay attention to. So yeah, that is it for that. Let's just move ahead. So come here and let's say our alpha is 0.01. Okay. So come and say lasso model dot fit s train y train. Before we do this, we'll try to train a linear model linear model, and we're going to see if there will be any difference. First, we'll see if our model is going to overfit, and if it doesn't, then if it does, we'll see how lasso regression handles the overfitting. So come here and say linear regression. Say lin model dot fit. Okay. X trend, Y trend, Y fit. Text. Hope everyone is following. Make sure you are following by pre-test. Um, Okay. All right. So let's see. Why bridge train? Why bridge train? So I think for those that don't understand this thing I'm doing now, this is another shortcut of converting your to a particular decimal point, right? So if you just put two here with f dot two f, right, followed by a colon, it's going to convert it to two decimal places. If you put dot three decimal places. So this is another notation that you can actually use. So let's see. Come change this to y right here. Okay, this is lasso. Oh yeah, lasso model. So you can see now that the score for the how to score for change it here. How to score how to score. So the how to score for the train data is what? 0.36. Why that for the test is 0.35? So is there overfitting in this particular model or not? We are using linear model here to train our this thing, our data. So this score now, does it indicate overfitting or not based on this score that we are seeing? Please let's look at this. Remember that this is not a classification problem. This is a regression problem. And make sure that you know the range of how to score here. Exactly. Yeah, thank you. Those that said no refitting, you are correct because yeah, based on this output score that we have here, there is no overfitting, right? It's just that the R2 score is quite low. That and understand what the R2 score mean based on what we discussed before. The R2 score is it measures how well your model predictions fit the actual data, and it ranges from 0 to 1. So 1 means perfect predictions, and 0 means that the model is no better than simply predicting the mean of the target. So this is not a really good how to score. but it also doesn't signify overfitting because the variance is low, right? So you can see the variance here is actually low, but the bias is very high. So this model has high variance and what high bias, which is like the worst case scenario when it comes to um, model evaluation, right? So since there's no overfitting, let's see if the lasso is going to do any difference. So you see the RT score for your lasso model, still the same thing basically. So generally, your your model for the two model are actually not performing very well, but it is also no overfitting. So let's just proceed to the other ones that we have. But you can see that the score for this was actually reduced here from what 0.36 to what 0.32, and that shows you the effect of regularization. So remember what I said about regularization, it kind of penalizes your model. It penalizing your model, it also means reducing how well your model fits your training data. So for the fact that we are having a lower score here shows you that yes, the L1 regularization in this lasso regression is penalizing the model. So let's assume you have 0.86 here as your R2 score and you use lasso, or let's say you have 0.96, right, which is a very high accuracy, right? Let's assume that it was overfit and use lasso, which is L1 regularization. Now you come here and you have 0.86. It shows you that the L1 regularization is working very well, right? Because the accuracy for the training data has reduced due to the penalty, right, that the regularization gave the model. So this is just how you can interpret some of these things. It's what you know already. It's just some new additional information that you need to add to what you already know. So that's it for L1 or lasso regression actually, because we can also use L1 regression in other models. So let's look at how we can do that. Let's go back to our material here. Or let's quickly use the ridge regression first. So for ridge regression, come and say ridge model first ridge. So you see the same thing here, alpha bar. So we can change alpha. So changing alpha here can actually change your model performance actually. So we've changed from 0.01 to 0.1. So we'll see how much of that it affects the model. So you can see now that it has actually it made the performance even much worse, right? So negative values in R2 score indicate that the model performs very it's so bad. Understand? So this means that you've actually over penalized your model. You understand? So this was what I was talking about initially. You've over penalized your model here. So let's go back. Let's see if we use 0.001. Let's see what will happen. So let's come and copy all this. Let's paste it here. We are going to train. This is for L2 regularization. L2 regularization. So you can see the difference now. You can see that the score here is 0.359, which is almost the same thing as this one, 0.36. If you approximate it to give it the same thing. So this is because the penalty that we give to our model, the regularization strength is very, very low. Very, 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 very low. So it's actually not even performing much regularization. So thereby still giving the same um, how to score as a model that doesn't have a regularizer. So I'm just trying to show you how tweaking this parameter here can affect the strength of your regularization. All right. So let's check out this. So this one is the same thing as well. So you can see ridge regression still doing the same. All right. So if I make this 0.001. So I believe you already have an idea of how regularization can be implemented using lasso model and ridge regression. So the same thing happens here as well. So that's it for lasso and ridge regression. This is when you're actually performing a regression task. So let's look at other implementation in other algorithms because we can actually also apply L1 and L2 regularization in in different other algorithms. So we've seen ridge here, we've seen lasso here as we've demonstrated. So you can actually also look at elastic nets. This is a combination of both L1 and L2. So I don't know if it's necessary to still show you, but these are the parameters alpha, which is this, and then L1 ratio. So this L1 ratio is just like test size when you are splitting your data set. So test size, if you indicate 0.2 as test size in your train test split method, what it means is that 20% of your data set will belong to the test data set, while 80% will belong to your train. The same thing happens here. L1 ratio basically means that this is the ratio of L1 regularization that would be used and the ratio of L2 regularization that will be used. So if I indicate 0.5, that means it will be equally shared. So L1 regularization will be used 50% on 50% of the model, and then L2 regularization will be used 50 on 50% of the model. So, but let's look at the documentation so we can read it and see exactly what it is doing. I will come here and import elastic net. So you're combining both L1 and L2, that is lasso and ridge, and using it on to train your data. So come here and say elastic model. Let's say elastic net alpha L1 ratio 0.2. So 0.2 means only 20% of violation will be based on L1, then 80% will be based on L2. So if I open this, you see, just scroll down and so you can see this is the elastic mixing parameter. So L1 ratio equals to 0 means that the penalty is an L2 penalty. L1 ratio equals to 1 means it will just be L1 regularizer. So anything between 0 and 1, that means the penalty is a combination of L1 and L2. So if I come here and say 0, what do I mean? I basically mean that this is going to be an L2 regularizer. So this is the same thing as what? Using ridge regression. All right. If I now come here and say 1, this is using the same thing as using lasso regression. Right? If it's anything between 0 and 1, like 0 point this, 0 point that, then it's a combination of ridge and lasso. So that is what elastic net is. Elastic net combines the two regularizer and use it to kind of build your model. So it's as straightforward as that. So you can try that on your own and see how well it performs in relation to or in comparison with what we've done already. So let's just move ahead. Let's move ahead. So now we're going to look at how we can use L1 and L2 regularization in logistic regression. So we will see that we can also use L1 or L2 in other tags as well. We can use it in classification tags. So let's quickly look at that. So come here and say using regularization and classification algorithms. So remember, only when you have overfitting problem that you would think of using regularization. If your model is not overfitting, you don't have to disturb yourself or bother yourself about all these things I'm talking about now. This is only when you realize that your model is what overfitting. And I've already showed us how you can know if your model is overfitting or not. All right. So regularization. So I've imported logistic already. So I'll come and say logistic log reg equals to logistic regression. So the logistic regression takes penalty. The penalty can be what L1 or what L2. If you look at the documentation, you're going to see there. Yes. I think I imported logistic regression. So you can see the penalty here. So by default, it is using reach L2 regularization, right? So if I scroll down to just read the documentation, you will see the penalty here. It is L1, L2, or elastic what net. So by default, it uses L2, and it also have this none parameter here. You can put the value to be none, so it doesn't use any regularization as well. So these are the explanation. No penalty is added. L2, it add the L2 penalty, and it is the default choice. Add the L1 penalty, then both L1 and L2 penalties are added. So that is it for using regularization with logistic regression. And something you also have to know is that some penalties may not work with some solvers. So these solvers is also a parameter in logistic regression. So you need to also be careful on the combination of solver and penalty that you're using. All right. So now let's come here and just change this to L1. You can see, let's import the data set that we can use for this. Import and load. Okay. Going to come here. Then come and split it as well. Split it. Log dot fit. So extreme fit. Predict, and I will say X test, right? So accuracy, accuracy. How to import accuracy score. I test well fit. So let's make this none first. Let's make it none, not using any regularization, right? So I'll come and say, so you can see that the accuracy is what 0.97. So let me make it for both train and test. Come and say train. This one is for test. I'll know if there's overfitting or not. Although for the fact that it's 0.97 on the test, it should show you that there's actually no overfitting because it's performing very well on the test as well. So, but let's see. Oh, oh, I'm supposed to make predictions for. Regularization. All right, so you can see it's giving us the same thing. So this is your ideal model performance. It should be high, low variance, and what low bias. So this is what we're having here. So there's no regularization happening, and your model is performing very well. So let's try with L1 regularization. So now you can see what I was talking about before, that some solver does not support some type of regularization, understand? So you would have to change the solver at this point if you want to use L1 regularization. But let's switch to L2 regularization first to see. So you can see that still yet nothing is changing here. But let's look at the solver. Let's see if we can change the solver so that we can use L1 regularization. So we have linear. We're going to use lib linear here. So I'm going to use L1 solver. So actually it is not changing anything. So let's see. Elastic. It's not doing so. Elastic net. Only Sega server. So you can see another error because of the incompatibility with the solver and the penalty. So only Saga server support Elastic Net. So let's change it to Saga here. Okay. One ratio. Point three. So still the same accuracy. So you can actually look at other metrics like the precision and the recall. if anything there actually change. You can do that on your own, but for this particular case, this is how you can implement or use L1, L2, or elastic net regularization on your on using logistic regression, right? So if you look at how we can use it in linear regression, and this is how we can use it in logistic regression, right? So that's basically it. That's basically the idea of using regularization in our model. We can use it as well in or support vector. So support vector takes a different parameter which is called C. So you can actually read it up and see what how you can implement it, how you can use it in ensuring the strength of your regularizer and all of that. So I'll also just give you as a take home, just for your own personal research. You can look at how regularization also comes in other algorithms that we've looked at, like the random forest decision trees and all of that. Check to see if they also support using regularizer and which regularizer they support and also how it can be implemented. All right, so that's it for regularization. It's just a side topic and is all only used when you are having a problem of overfitting. When you have an overfitting problem in your model, then you can now consider using regularizer. But when you are not, don't disturb yourself. Just the model is fine. All right, you don't need to do everything that everything that you see is not necessary to be you don't need to implement every single one of these things that we are looking at or discussing. It's just to know when and where to use it or implement them. All right, so that's it for that. Okay, so these are just some other things about regularizer. You can look them up in the material as well. So these are the summary, importance of regularization in preventing overfitting, and just some final thoughts. So always consider regularization in your machine learning models. Use cross-validation to tune regularization parameters and avoid overfitting. Choose the right regularization technique based on your data set characteristics. So I believe this will give you a good starting point of using regularizers and implementing them in your model when there is overfitting. So that's going to be it for regularization. And as I said, we are going to look at something else, which is how to compare different models using our ROC score, right? So I said I'm going to do that. So let's just quickly look at that. So after that, then I'm going to show us how we can save our model as a file. All right. So let's go straight to that. All right, so I introduced ROC curve when we were looking at logistic regression few weeks back. So I told us it's an evaluation. I told us it's an evaluation technique to see how well our model is performing. So we can use it on a single model, and we can also use it to check how well our model compares to other models. So it's usually represented in a graph. All right. All other evaluation metric we've been looking at, they are mostly numbers or table, or maybe when you're using your conversion matrix and all of that. But this one is a graph. It shows you how well a model is performing on a graph. So let's just look at that. So we've trained a linear regression, a logistic regression model, and this is for classification task. You don't use it for regression tasks, for classification tasks. So since we've created a model using logistic regression. So we are going to see how to use classification ROC curve in seeing how well the model is performing. So before I proceed, I just want to be sure that we are all still following. Please let me get the feedback in the live chat. All right. So let me quickly look for something. Think or introduce logistic regression. All right, so this was the ROC curve I introduced to us during our logistic regression class. So just to recap, our ROC curve is what is a graphical representation of a classifier's performance across different thresholds. All right. So, but what we want to use it for today, we want to use it to compare for different models different models that we've created to see how one is performing. You can as well use it to compare how a single model is performing using different thresholds. Remember what I told us about threshold? Threshold is like the cutoff point where you classify this as either class one or class two. The threshold can be 0.5, 0.3, 0.4, 0.7, and all of that. But we're going to look at how we can use it to compare the performance of different models. If time still permits, we also look at how we can use it to compare across different thresholds so you know how where your model is performing. And the ROC curve is a curve that it plots the true positive rate against the false positive rate. So before you can get your ROC curve, you need to compute your true positive rate and compute your false positive rate and then plot it on a graph. So you're going to see. So now I told us the other time that your curve, the ideal curve should be something that touches this particular corner, this top left corner here. So any curve that is close to this top left corner is a perfect classifier, is a very good classifier. So the further it is away from this corner here, the worse the worse your model is performing your model performance is, right? So but the closer it is to this particular point, the better your model. Okay, so you can see we have different these lines here that we can see, they represent different models. So this might be logistic regression, this blue one might be logistic regression, this yellow one might be decision tree, this green one might be KNN, and this one is just a random classifier. So you can see that out of these three models, the one that is performing best is what? This blue one, which is your logistic regression. So this is a visual representation of different model performance. So it's a very good way to evaluate models, all right? So let's just look at how we can implement it. So now I said you have to compute to get that you have to compute your FPR, false positive ratio, and true positive ratio. So before you do that, you have to like compute what we call predict prober. There's what we call predict prober. Some of you might be just wondering, when is all this going to end? Like, the truth is that data science is very, very large. Like, the syllabus is quite large. Even if we have some more time added, we might still not be able to even cover every single thing. So these are just some additional things that I feel it's necessary for you to know. Okay, so just take your time, even if you've not grasped every single thing right till up to now. It's actually very fine. After this, you can as well take your more time to go over those concepts that you realize that you've not perfectly understand. All right, so it's fine if everything has not been cemented yet. So let's proceed. So I said we're going to have to get the predict proper values. So we have our predict normal predict method. We also have another method called predict proper. So if I come here and say log reg dot predict proper. So what this does is that it does not give us ones and zeros, right? It gives us the probability itself. So I'll come here and say x test. If I run this, you see that it gives us probability values. So you can see this one is 0.05, so 0.05 or 0.5. This one is 0.9, this one is 0.9, 0.15, 0.2, and so on and so forth. So you can see the probability. This is the original prediction before it is now classified based on thresholds, right? This is the original prediction that your model predicts. Your normal predict value, which is this, if I remove this prober here, and just say predict, this is what it's going to predict for 0, 0, 0, 1, 1, 1. So this one is the final prediction after it has classified each probability based on a certain threshold into a class. So if the threshold is 0.5, if your predict proper value is 0.3, it's going to classify it into class 0. So this is the final prediction that we use. But we also have another one which is called predict proper. So it gives you the probability values itself. So if you check it, you see that the returned estimate for all classes are ordered by label of classes, blah, blah, blah. So you can read it and just see exactly what it is doing. So this is what you need for your ROC curve. So you just have to assign it and say y pred proper. Just assign it now. All right. So that's the first step, okay? But now you need to actually extract a particular section of that the return values, because this predict probability. There's something I even failed to tell you. Let me come here. So this predict proper here now, it's actually predicting the probability of the zero class and the other class. So this is class 0 and class 1. So this class here belongs to this first value here is the prediction of the first class. Let's say in this case class 0, and this one here is the prediction of the second class, which is what, class 1. So what you have to do is just to extract any of the classes here, because you don't need to use the two. So to do that, you just come here and extract it by saying let me make it simpler. Come here and say you use your indexing or your slicing that you already know. So you say 0 or 1. Let me say 1. Right. You can use either of them here. So come and say y read rubber. Then I will give you that. So that is the first step. That's the first step. So now the next step is to calculate your FPR, TPR, and your threshold values, because those are the things you're going to need to plot your AUC, your ROC curve. So to do that, you would come here and say ROC curve equals to what? Y test, right, which is your true values, and what your Y pred proper. All right. So it returns three values. So you have to unpack them. The first one is your FPR, false positive ratio. Second one is your TPR, true positive ratio, and the third one are actually thresholds. Okay. So this is basically how you unpack it. So this is the second step after you've gotten your predictions, the probability predictions. You get your FPR, TPR, and your threshold value. Now you need to calculate your AUC score. I know this is getting actually lengthy. So you come and say AUC. I think we've imported AUC. AUC is equals to FPR and what? TPR. So this is how you calculate your AUC. I think you have to import AUC here. Come here and say AUC. AUC. Okay. So come and say AUC. So you can see that the AUC is 0.97. So it's almost the same thing as your accuracy score, which is good. So come and say AUC score. All right. This is the third step. Calculate your probability values, get your FPR, TPR, and threshold, get your AUC score, and now you're ready to plot. Okay. So now to plot, you just use your normal plot function from matplotlib. You come and say plotting your ROC curve. Come and say plot dot plot. And come and you say FPR against TPR. This is how we plot it, but there are other things you need to indicate here to make more sense. So you can see we've plotted it here. We can see the curve I was telling you about. So I can come and say label is equals to, we want to give our AUC score, right? And say F AUC score is equals to AUC score to F. All right, then we plot your Y label to be, okay, sorry, should be this. The Y label should be false positive ratio plot dot X label true positive ratio. Then plot your title. Title should be ROC curve. Okay, so that's going to be it. Come on, so plot the show. So you can see now that this is our ROC curve. Oh, okay. Let's plot our legend. So we'll see our AUC score. So you can see it now. This is your ROC curve. This is how it looks like. This is just for one model, all right? This is for logistic regression model. Now we can actually plot it for different models in the same graph. So you can see the same way we have this here, same way we have all this here, we can have them, every single one of them in the same graph. So you can compare your models and see which one is performing better. All right. So how to do that is a good way to present your model performance to somebody, right? I'm also giving you this. I'm actually taking my time to show you this because I would like you to also implement it in your project as well, because you'll be using several models to train, and you can You can use this thing to compare the performance of the models in a graphical format. So once someone sees it, they can be like, okay, see the model that's performing very well. So how can we now bring in different models? So in this case, I'm just going to use two models because of time. So I'm going to use tree, decision tree. So I'll come and say tree, decision tree. Let me import it here. SQL tree. Import um decision tree classifier, right? So come here and say tree classifier. So nothing special, just come here and say tree.bit x train y train. All right. So now this is where we're now starting. We're going to start naming them separately. So y pre train. This one is okay. Y pre test. This one is for log. Come here and say y. I'm not using this. I'm using predict proper actually. So come here and say y read proper tree. All right. I'll come and change this on to logistic regression. Just copy this. Put here. Okay. Do the same for this. Log. Say tree. That should be log. So I hope you're all following with this. It'll be a little bit confusing, but if you pay attention, you should understand it. So this one should be log. So yeah, I'm doing the same thing for all of them twice. So FPR log, FPR, TPL log. All right. So comment say FPR log, TPL log, AUC score log. So I have to copy this and replicate it for decision tree as well. So I'll say tree, 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 tree. All right, now I'm not going to plot it again. AUC score, so I should go for logistic reg AUC score, or just logistic reg AUC score, and then copy this. It should be AUC score log. I think um, here is that the two model are exactly the same. So that is they are actually overlapping each other. That is why you probably can't see them. But let me see if there's anything I can do to make them come out. And let me just use KNN, KNN, KNN. So this is basically because of our data set, all right? Once you have a data set that is not, because most of these scaling data set, they'll give you a good performance, obviously, because they've been cleaned and they are arranged in a way that you will not really like have much issue. But once you're working with real life data set, trust me, you'll not be getting this kind of performance, 98% and the rest. It's very, very difficult to get that on a real life data set. So let me just say neighbors import. This is just to show you. Okay, import classifier. I just have to change this to okay, and then import classifier and next. All right. So one thing that I do is that one is that your end understand because when you have to for one two of that so it be even so the best is always to use odd numbers. I mean, right? So yeah, um, can you imagine the results? Just saw the problem now. Exactly. No, but I just saw it now that I use log reg to predict. Okay, I think you've all been. Yeah, I use log reg to predict instead of tree. That was the issue, right? Exactly. So you can see it now because there's no way two model will give you exactly the same performance. So see, you can see now the ROC curve and the score for the two models. So based on this, you see that logistic regression is giving a better performance here with ROC of 0.98. So you can see the curve is actually better. It is like if you check it overall, you see that it is better than this other one, which is the decision tree curve. So let's add another one. Since I brought in KNN, let's just add KNN here. So I'll just copy and paste, copy and paste, and say KNN. Come on, say KNN. Copy this. Thank you very much, Michael, for pointing that out. KNN. Copy this. KNN. Let's change everything to KNN. 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 Then come here and add another plot. Change it to what? KNN. And change it to what? KNN. So if I run this, was okay. Um, Okay, I just remembered. KNN doesn't have predict proper, I guess. Am I sure? You should have your safe predict proper. This can- Okay. I have not fitted my KNN yet. So fit train, Y train, um, KNN predict proper. All right. We're just going to leave this out. I don't want to waste time like debugging because we we just covered the basic idea of that. So you can just check that one out on your own and see exactly how KNN performs as well. So I don't want to waste time on figuring out what the issue is. So you can take that as a task, your own personal task. So this is it for ROC curve. So you can add as many other model as well. So where is that? Okay. Um, thank you. Yeah, sometimes thank you very much. Sometimes you just not see some things that is close to you and people might like see them better. So that's why I have you all here. Thank you for pointing that out. So you can see now that we have three models here. We have the logistic decision and KNN and see how well they are all performing. So that's it for ROC curve. You can see that we've used this to compare the three different models, and you can see across these three, KNN is actually the best in this particular set of models. So that's it for ROC. It's a very good way to compare classification models. So I'm expecting you to use this in your project. That's why I'm taking this whole time to show you all these things, right? If not, I would have just told you to go and figure it out or giving you materials on it. But you should try to use this. It's a very good way of presenting your evaluation, your classification evaluation is a very good way of presenting it. So yeah, that's it for that. We've come to the end of all of all of what we're supposed to look at today. So to wrap up, I'm just going to show us how we can save our model. All right. So I said I'm going to show you how to do that. So it's very simple. To save your model, you need to import a library. So you can use two libraries. You can use Piku. Let me come here. You can use either Piku or joblib. All right. So to do that, you have to import them. Import joblib. and what pickle. So if you check them out, you see that this is what it is used for and everything that you need to know. So pickle as well. So pickle is, I think pickle is built into Python, but joblib is not. I need to confirm that. So in case you are importing any of these and they are not important, they're giving you an error, just install it using pip install, as I've showed you before. Pip install joblib. All right. So you can just do that and it will automatically install the library for you. So once you've installed the job lib or the pickle library, you can now simply use it to save your model. So how do you do that? For job lib, so you can say I've installed job lib already. So I think this is the one you need to install because it does not come in with Python. So pickle is already there. So for job lib, using job lib, what you do, very straightforward, using to save your model. So how do you do it? All right. You come and say job lib dot dump and then your model name. Remember, we've created so many models. So the model we're going to dump now is our logistic model, log reg. That is the first parameter. Second parameter is the file name. So you can come and say logistic model. All right. Or any model, or whatever name you want to give it, you can give it logistic model dot pkl. So this is the extension that it is saved in .pkl. So you close the bracket, all right, and then enter. It has saved already. So if I go to my file, the location where I am working, you can come here. You see the model here. You can see it, right? Logistic model.pkl, pkl, all right, pkl. So you can transfer this or send it to anybody and they can load the model in their laptop and use it to make predictions. So this is how you can save model and transfer it from one place to another and all of that. You can see that the model is only 2 KB because it does not have plenty. The knowledge it has is not plenty. But when you are training a large model, like a model with like 1,000 data sets and that has a lot of parameters, the model will be larger. It can be like up to 3 MB, 4 MB, 5 MB. So depending on your model size, the model size is going to determine the file size of that particular model file. So that's how you can save your model using joblib. So if you want to load it, like let's say someone sent you a model that they save and you want to load it, I can come here and just say model, and let me create new notebook. Let's say I'm on a new notebook entirely and I have that model, right? Make sure that you are in the same working direction. Working directory, right? So I'll come here and say import joblib, all right? Come here and say model equal to joblib dot load. I want to load the model that I have saved, all right? And then you say logistic. Don't think this one does the same thing. Logistic model dot pkl. Okay, I want to be sure I'm in the same working directory. But let me just open it here so that I will not have to go through that. So just ensure that you're in the same working directory. Very, very important, unless you're going to get error. Or you either specify the full path or you just make sure you're in the same working directory. So I'll come here again and say job lib. And then I'll come and say model. You create a variable which you are going to load the model into joblib.load. And you say logistic model.pkl. So you load it, you should load without problem. So I can come here and just say model you can see that it has brought in everything that the model has, all the training parameters, the thing that we've done in the previous Jupyter notebook, everything is here. So I can always come and say model dot predict, right? If I have my data set, I can just put it here and it's going to make my predictions. All right. So because there's no data set there, right, it will give me an error. So that is just how you can save your model and transfer it with using JobLib. So your project should contain this aspect. You can see that in the project document, I indicated that you save your model as well. So you can use another let me go back here. You can use another library, which is Pickle. So Pickle is another method of doing the same thing. So to use Pickle, you've imported Pickle already. So to save the model, you just say with there's what we call context manager in Python. That one is most complex than this JobLib. So you can always just use JobLib to save your model, so you not stress yourself. But Pico, you just come here using Python context manager. So context manager is a concept in Python. We didn't look at it because it's not we are not going to be using it so much like that, but it has to do with using this with keyword. You say with open. So what it does is that it opens the file that you want to save it into. So let me call it logistic, or let me say decision tree model dot pickle. All right. So and it takes another parameter. So all these things are just some things that you need to know in Python. This is Python context manager in action. I don't have time to start explain every single thing, but this is just the syntax you follow. And after that, you press enter. It is going to make an indentation for you, like you're writing a function, that kind of thing. So everything that is under it is still part of this with context manager. So you come in and say pickle dot dump. All right, and you put your model name tree, right, and then this F that you have here. So once you do that, it will save it. So if I come to this thing, you should see it there, decision tree model. You can see decision tree model dot pickle, and you have that saved. If I want to load it, I'll also use the same context manager. Come to a new notebook. All right, come to a new notebook here and say with open decision tree model picker, and you say read binary. This read, that is when you want to read a file. This R is for read, while the W I did before is write. So if you want to save something into your system, you use W. If you want to load it with context manager, you use R. So this B is binary basically, because the file is a binary file. All right, so these are just some things in Python. Come and say as F is alias. It's just an alias. So you can come and like the same thing as JobLib model equal to pickle dot load F. Then you have to import pickle. So come here and say import pickle. So you have your model. I can come here and say model. You see that it's the decision tree class, right? So that is how you can save your model and just play around with it. So that is the entire flow of machine learning, from collecting your data and importing your data to building your model and saving it and all of that. So I believe we've been able to cover the necessary grounds and the foundations in ML. So with all of the things we've been doing so far in the past 11 weeks, I'm certain that you are well equipped to carry out any task, right? That involves machine learning. Now, I don't want you to stop here. Please and please, there are a lot of things to learn. If you want to be distinguished, you want to set yourself apart, still go ahead and try to understand better some of these things that we've looked at or revise what we've looked at already, because I believe and I know that um, we've looked at a lot of things and it might be overwhelming for us. So take your time, and this project should help you as well, and just help you build confidence and just solidify your ground in machine learning and data science. That's going to be it for today's class, and that is going to be it for this course. We've finally come to the end of data science of Youth Thrive data science program. I wish there's a way for everybody clap or something, but that's it. That's it. That's a wrap. It's a wrap at this point, and I'm very happy. And I'm happy. I don't even know what else to say. I'm just happy that we are able to make it up until this point, right? I know that a lot of us have dropped for several reasons and for things that are beyond our power and all of that. But I believe it's all for the best. So yeah, for those of us that are still here, you just give yourself a round of applause. You've tried. You've through thick and thin, you've persisted. I can understand the technicalities and the complexity that is involved in learning data science. Trust me, especially for those that are entirely new, that are new to data science. It's not straightforward. It is not something. It is not just even coding. Like that is the thing about data science. Data science is not just coding. You have to learn some abstract concept. You have to learn some mathematical concept. You have to learn some statistical concept. You have to learn some all other things, theoretical aspect and all of that, coupled with the coding. So for you to have made it up until this point, see, you should believe so much in yourself now that there's nothing that you can't do. The only thing that it will take is time. All right. So the only way from here is up. Right. You've started it already. You've started climbing the ladder already. So the only thing that can stop you is actually you. So that is just what I'm going to say. Please don't stop here. Don't stop learning. If you want to become good at this, please don't stop learning. If you stop learning at a particular point, you might start to lose some of these things. All right. So you should just keep up with it. There are lots still to learn. Even with all these things we've learned, there are actually more to learn. Especially those of us that want to specialize in ML, there are a lot more advanced things. Trust me, when you start moving, you will see that there are a lot more to learn. So if you can have a solid ground on these things, it will be easier. It will make your way or your learning the more advanced one easier, way easier. So, because I know some persons that actually try to jump this particular step into going into deep learning and AI and all of that. It's not like you won't learn it, but it is going to be very difficult for you because there are some fundamental concepts you need to understand and learn first before all of that. So, yeah, this is a good thing. And this opportunity is a very rare opportunity, trust me. I've said this before that if you want to learn data science, especially this kind of using this kind of learning pattern where we have live classes, trust me, there are not plenty learning platform that uses this learning pattern. Most of them we just use recorded videos and maybe once in a while live class and all of that. But we have consistent live classes every week, 2 weeks, and that particular experience does something different to you. Trust me. If you've taken a course before where there is no direct interaction with you and the tutor, it doesn't hit home as it would when you have a direct interaction in live class. You hear them speaking live and all of that. it it hits differently, and you tend to pay more attention. So I can't start to explain the importance of that. So this opportunity is not to be taken for granted. Like if you are to do this, like if you are to take this class all by yourself, paying for it, I don't want to start mentioning how much you are going to have to bring out from your pocket to do this. So you should be grateful to the people that gave you this or made this opportunity available, and for the fact that you didn't misuse it is wonderful as well. So please, I want to see you at the top. I want to see you doing things like in data science, even at some point, even teaching people data science. Right? With what you know now, you can actually start to teach. You can actually start to just explain concept to people and all of that. If you are working already, and they are actually implementing some of these things, now you actually understand them, and you can actually now start to give your input and all of that. And trust me, if you're in that kind of environment and they see a kind of growth in regards to machine learning and data science, then you definitely have promotion, right? Salary raise and all the good things that comes with that. So just look for a way to maximize what you've learned. I don't know how. I can actually um, start to tailor it to your own specific case, but you know yourself best. Look for a way to maximize this opportunity. All right. There was someone that chatted me up, I think this evening, was telling me he got a role with in a team that is doing something. And it's nice to hear. Like he's one of our students here. It's actually very, very nice to hear. So the opportunity that is ahead of you is numerous. So it just depends on you at this point. So that is going to be it for this program. I said before that we're going to have some time to just to say certain things, but because of time, I think we should just keep it in the group chat. So just whatever it is that you want to say, just say it in the group chat. Let everybody see it, and we're going to just interact there, like after the class. It's actually been very wonderful teaching you all. Um, Everybody had their challenges. I myself had my challenges. So I believe if everyone start talking about it, we would we would not live here today. Um, so that is going to be it for for now, because we are still going to see. Yeah. Um, After the project, some of you will be doing your project defense, so we are going to meet there, and some of us will also be taken into the next phase of this program, which is the incubation program, where you have to work where you will have to work with other people in front end, back end, cybersecurity program managers to build a particular app or a product. So it's not ending here. Yeah, it's not ending here. So all the things you've learned, you're going to utilize them and see how you can implement them in the real world. So I'm going to be drawing the curtain here. If you have any question, um, you can ask that as relating to this class. If there's any other personal question that you might want to ask, can always ask, come to my DM for that. And your project as well, if you still have issues with your project or questions, please ask me. If it's a general something error, please post it in the group chat. I believe you all would attend to one another. So that's it. Thank you very much for having me. Thank you for your attention so far, and thank you for sticking with us up to now. So I'll be giving rooms for question now, and then we call it a day.
Good evening, sir. Hello, sir. Should I go on? Hello?